Series part 1. Well, all right, let's just start. Go ahead and read it. Go ahead and read it, and then we'll come back. All right, so go ahead and assume that you read this. The study in question is focused on the student population at Cal Poly. Boom, population of Cal Poly students. The aim is to investigate which type of candy, milk, or chocolate, milk chocolate or white chocolate, dissolves faster in a student's mouth. The entire student body at Cal Poly forms the population for the study. However, the sample that we have access to for this study is limited to 63 students from a business class. Boom, our sample. These students participated in the study by placing a piece of candy in their mouth and measuring the time it takes for the candy to completely dissolve. The experiment was conducted in the following manner. Each student was asked to check the day of the month they were born. If it was an even number, they started with the milk chocolate. If it was an odd number, they started with the white chocolate. They then placed the piece of candy in their mouth and measured the time it took for the candy to completely dissolve. The students recorded their time in the Google survey. The variables of interest in this study are the types of chocolate, categorical binary, milk chocolate, white chocolate, and the time it takes for the chocolate to dissolve, quantitative. The main focus on the difference in time to dissolve the white chocolate and milk chocolate. This is a quantitative variable, okay? Watch this again. I need to emphasize this. The main focus is on the difference in time to dissolve the white chocolate and milk chocolate. This is a quantitative variable, because just the difference, that will provide insights in which type of chocolate dissolves faster. So this is a tad bit different from the number of letters memorized, in that each person, each observational unit is experiencing both milk chocolate and white chocolate. Okay, so there's a confounding variable, or not there is a person to person, my apologies, a person to person characteristic that we need to account for, and the way we go about accounting for this is having them experience both chocolates. So with that being said, I'm going to assume that you went ahead and looked at the SSVA, the Summary Statistics Visualization and Analysis. Okay? And you notice that the mean of the differences is negative 3.09. The standard deviation of the difference is 13.49. The sample size is 63. The visualization is just a simple box plot. And it's our median. Okay, this is our median. It's below 0. If that makes sense. And then these are the outliers. Okay, so on and so forth. And finally, this is our analysis. Okay, this is the test statistic. Hopefully getting the pattern. This is the degrees of freedom. This is the p-value. Okay, this is the confidence interval. And this is the mean of the differences. So I'm going to legitimately pause again and have you all do what? Answer the conceptual questions. Answer the conceptual questions. All right, so shall we begin? Yes, we shall. So what would the population be? Sample size and observation unit be. The population will be all Cal Poly students. The sample size will be 63 business students. And then the observation unit is going to be a Cal Poly student, okay? Boom. How many variables? Don't say 2. Just 1. We're only analyzing 1, okay, which is going to be the difference in time to dissolve the chocolate in one's mouth, okay? What is the research question? We want to know if the dissolve time for milk chocolate and white chocolate are the same, okay? And how do we address that? With the paired t-test, okay? With the paired t-test, okay? And so since we're implementing the paired t-test, we were looking at the difference in times. How many mu's should we have? 1 or 2? In the back of your mind, if you said 1, good job. It's just going to be mu d, which represents the population mean of the differences. Okay, this is different from the 2 independent population means in that you're looking at the difference between populations. Whereas now you're looking at the population mean of the differences, okay, in time to dissolve the white chocolate and milk chocolate. Okay. And so, with that being said, question 5, state the summary statistic used to estimate the parameter of interest. That's just going to be x bar d. Okay, x bar d should be 3.5, negative 3.09. Wow, negative 3.09, and then which is the sample mean of the differences in time to dissolve the white chocolate and milk chocolate. So that's that. And that's the same thing. This is the same. This is the point estimate. Sorry, this is the point estimate. Okay. All right. So then question 6 should be hypothesis testing, right? State the null and alternative. Yes, it is. Okay. 6 says state the null and alternative hypothesis using words and symbols. Okay. Using words, it would simply just be, using symbols to be mu d is equal to 0 versus mu d not equal to 0 for the alternative. Okay. Whereas using words, we say that the population mean that the difference is the same or equal to 0. And then for the alternative, that the population mean that the difference is not equal to 0 or is not the same. Okay. But at the same time, at that additional context. What assumptions needs to be made? One assumption is that randomization has to be implemented in some way, in some shape or form. And that's what was done in terms of having the students have their birth date determine which chocolate they did first. Okay? Because if everyone did white chocolate first, therefore that would be a confounding variable. The order of chocolate would be a confounding variable in that everyone did white chocolate first. Okay? And then there needs to be an association between the groups. Okay? In the two independent population means test, they were independent. Whereas in this situation, we need them to be dependent. Some association. Okay? Calculate the test statistic. This is going to look very similar to what you've seen in the past. This is the same thing as one population means. Okay? Draw the distribution. What are the implications of the test statistic being more than 3.5 standard errors from 0? Technically, in this situation, we already know the test statistic, right? It's already given to us. It's 1.82. And we just confirm it by utilizing this equation here. Okay? And once you do that, you see that it is negative 1.82. That is our test statistic. Well, we can't determine, well, we know that it's less than 3.5, or it's greater than negative 3.5, indicating that it could be close to 0. But this p-value right next to it tells us exactly where it is, indicating that we have some evidence against the hypothesis. We have some evidence. We don't have a lot of evidence, but we have some evidence that the population means are not the same. Okay? So if I were to draw this out, I would have a vertical line here because in the middle is 0. It's negative. It's going to be somewhere around here, I would think. And then it'll be the area underneath the curve. That'll be the p-value. Okay? That'll be the corresponding p-value. What else does it say to do? What type of evidence? We have some evidence against the null hypothesis. All right. From there, it says state the point estimate. Calculate the 90% confidence interval for the parameter of interest. Degrees of freedom is 62. The critical value is going to be 1.6698 based on the degrees of freedom being 62. What assumptions need to be made in order to implement this statistical technique? All right, so here, calculating the confidence interval, I jumped a little bit. I provided the answer. We are 90% confident the population mean of differences in time to dissolve white chocolate and milk chocolate is 0.25 and 5.93. Okay, so our point estimate is negative 3.09. And how do we get these two values? First of all, it's from our output, which you can confirm it by utilizing this critical value and the standard error. So the standard error is this doohickey here. So I'm going to copy and paste this here. The standard error to confirm is going to be equal to what we have here. And you can find the exact values and confirm my results. But that will be our standard error, and the critical value is already given to you right here. So you can confirm the values, okay? This should be below. But that's fine. the data was random, there's an association between the two groups. And again, the implications of 0 being within the lower bound, upper bound are the same for pair t-test as it was for two independent population means. In that if 0's within the lower bound, upper bound, it's indicative that it's plausible that there to be no difference between, or there's no difference between the population mean of the differences. Sorry, got a lot of words there. So if 0 is within the lower bound, upper bound, it's plausible for there to be no difference between the dissolve time of the chocolates. But if 0 is based on the data, but if 0 is not within based on the data, it's indicative of that it's plausible for there to be a difference in the dissolve time. And since both of the lower bound, upper bound are both positive, and I believe the way it was done, it's opposite. Hopefully you cut that. So this is positive, and in the graph it's negative, right? What that's telling me is that in both the lower bound, this is all positive. I'm thinking that, how did they calculate this? Dissolve time. I believe it's white chocolate minus milk chocolate, which indicates that white chocolate, it takes more time to dissolve white chocolate than it does to dissolve milk chocolate. I'll say that again. It takes more time to dissolve white chocolate than it does to dissolve milk chocolate. All right? Because both the lower bound and upper bound are positive. All right, so what are the implications of 0 being within the lower bound, upper bound? If 0 is within the lower bound, upper bound, then based on the data, it's plausible that there is no difference between the time to dissolve milk chocolate and white chocolate. Since 0 is now within the lower bound, upper bound, we can say that it's plausible that there is a difference between the time to dissolve milk chocolate and white chocolate based on the data. Okay? So here, as the p-value gets smaller, this is totally separate. Just this gives you an idea what's going on. As the p-value gets smaller, does the likelihood of 0 being within the lower bound, upper bound increase or decrease? As you get more and more evidence against the null hypothesis, the likelihood of 0 being within the lower bound and upper bound gets closer and closer to 0. Okay, as the p-value gets smaller, it becomes less and less likely for 0 to be within the lower bound and upper bound, because you have more and more evidence to reject the null hypothesis that 0 is even plausible as a difference. Okay, so that is that. How long did that take? I think it's about 13 minutes. That's not bad for this video. With that being said, we're done.